Good morning, everybody. How we doing? Live from the studios in New Orleans, Louisiana. We're here today, and we're getting ready to tackle the big boy with regard to weather. That, of course, is going to be thunderstorms, Chapter 34. Turn in your hymnals. Chapter 34. As we get started here and you guys get ready to go and kind of follow along here, we've got our new studio lighting in here right now. I'm not sure what I think about it yet. I still have to kind of play with some settings, so we're going to get things figured out here before too long with all of this. So we have our new audio in, we have our new lights in, so you know, hopefully that's going to be a thing. You can see that we have one of our screens in here behind us now, so you know, we're going to start to look more and more like a professional organization. Pardon me whilst I sip. So I spent 4 hours of my life yesterday in one of the parishes. That's what they call them down here. They're not counties, they're parishes. And 4 hours of my life at the Division of Motor Vehicles, or the Division of Misery and Vacuous Behavior, as far as I can tell. And I mean, it was just the most infuriating thing. Oh my Lord, it's just at some point you get in some form of a bureaucracy which evidently does not allow logical thought. And it's just amazing. And I think that that's one of the things that with regards to education that we strive to equip you with as you go out there into this big bad world of ours, is just the ability to think and the ability to say, you know what, guys, wouldn't it be easier if we did this? Wouldn't it be better for this? Wouldn't it be, even though that we're in a bureaucracy, to realize that these people are giving us money, and the reason that I get a paycheck is because they're giving us money, and so therefore some form of customer service might be in order? Okay, well, those of you that have not had the opportunity to check that out, well, you're going to be in luck. I'm going to check our views here, just make sure that we're all still hitting on all 8, and we are good. So we're going to pop right in here now to thunderstorms. So we look at thunderstorms, and a thunderstorm, it can be one large cumulonimbus cloud. Remember what the nomenclature here, and remember what all of those prefixes and suffixes mean here with regard to clouds. It can be one great big cloud, or it can be a series of clouds that can cause some of the most hazardous weather to aircraft. We realize we're not going to fly through a tornado. Well, hopefully we realize we're not going to fly through a tornado. And we also understand that it takes a special kind of aircraft, special type of training, special blah, 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 to even fly in and around hurricanes the way the hurricane hunters do, to provide us scientific data. So it's just thunderstorms, however, you don't hear about you know, many scientific efforts to fly through a thunderstorm. You know why? Every encounter with thunderstorms, normally it ends poorly. So we don't want to do that. Now, you guys are going to read clearly about the thunderstorms here. But my guess is you already have. Why? Because you're just the studious type of people that you are. Remember that when we talk in our books here, we talk about a thunderstorm. What must always be present in a thunderstorm? Lightning. And the reason that lightning has to be present is because without lightning there would be no sound. Without any sound there wouldn't be any thunder, and we would call it something else. We would call it a big black cloud. But we call them thunderstorms because of the lightning. Now it also says right here, just underneath figure 34.1, thunderstorms must be avoided. See? It says so right there. So there we go. What does it take for a thunderstorm to happen? You've got to have 3 conditions, ding, 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 3 conditions in order for a thunderstorm to develop. First of all, you have to have some form of atmospheric instability. And it's the type of thing here where, excuse me, You have, you know how we talked about a standard lapse rate of 2 degrees Celsius per 1,000 feet, you know, that change in the atmosphere. Well, for thunderstorms to develop, you're going to have a more unstable lapse rate, and that air is going to be moving upward rapidly. Then you also have to have enough moisture in the air for these clouds to form. And then you've got to have some kind of a triggering action. And so that triggering action piece is that going to be some form of convection. It could be orographic with regards to a mountain. You could have a front moving underneath something, shoving air straight up, like for instance a cold front overtaking a warm front. Classic as far as creating a thunderstorm. Even some forms of advection, let's say, that can also move air upward quickly. And so you've got to have some kind of that triggering action. So atmospheric instability, enough water vapor in the air or a high humidity, high moisture content, and some triggering action. And those triggering actions are listed below in those bullet points. So there are various stages of a thunderstorm, and these things are all good to know. In fact, every syllable that escapes my lips is good to know. So the life cycle of thunderstorms, we look at the first stage, and the first stage is what we refer to as the cumulus stage. This is also the development phase of a thunderstorm. If you look at the picture there, the illustration on 34.2, you can see that you have huge updrafts. Now remember, those updrafts come from all around the base of this cumulus cloud that is forming with the beginning stages of a great deal of vertical development. When that happens, all of this air gets sucked up into this developing cloud, this potential developing storm. Now remember, even some of the light fluffies that we see out there from time to time, they still get air moving up underneath them to build these clouds, to kind of make them, if you will. But these thunderstorms, the development of these big cumulonimbus clouds, they pull even harder. So you have to kind of be aware of where they are, where those cloud bases are, and you guys saw the formula about how to calculate cloud bases. And understand that that air is going to be pulled from everywhere. So for instance, if you have a thunderstorm developing to the west of an airfield, whereas the normal airflow could be from west to east, you need to be aware that with that storm brewing to the west, that air can be pulled from the east. So you could get airflow from the east to the west as that is pulling. Why is that important? Well, let's say for instance you're coming in to land at an airfield and you normally land from the west to the east. Well, in this case, that airflow, you might expect it to be reverse, pulling that air from the east to the west, and you may have to turn around and land the other direction. So you got to keep that in mind. You always want to land into the wind, but you got to know which way the wind is blowing, right? Well, here's a way that you can somewhat predict the type of breezes somewhere near a thunderstorm as those are developing. So we look at this, and so another thing that kind of defines the cumulus stage is constant updrafts. Everything is an updraft, as we have just talked about. The mature stage. This is the one where you know, lightning, thunder, rain, hail, cats, dogs living together, complete chaos. This is where you're going to find, you know, the huge effects of a thunderstorm. And when I say the huge effects, we'll talk about the final stage of thunderstorms, because those can also have pretty strong effects here as well. But when you look at this, now, in addition to the updrafts, now you're also going to have downdrafts. And it's hard to predict where they're actually going to be. You'll see in the illustrations that we're going to look at here momentarily that there are some times where you can somewhat predict what's going to happen, but it's almost impossible to predict exactly what's going to happen. You have a pretty good idea, but that doesn't always pan out. So you've got updrafts, downdrafts, now the rain begins to fall, and the thing about the updrafts and the downdrafts is that you still have air moving into this storm to create more of this energy for this storm. Then you have these big columns of air moving down, rapidly rising air, rapidly falling air right through here. So can you kind of see why we want to avoid those things? Because I mean, those things, they just literally have the effect of sawing an airplane in half. And that's just, I think, bad juju. So let's just not have it. So we look here, the cloud tops of these things, they say that it can be 50,000 feet in the tropics. Well, we've seen examples here in the continental United States, well above the tropic zone, that we have had cloud tops of 60,000 feet. These things get so tall that even the big boys out there, they cannot fly over them. We have had these storms basically interrupt air travel throughout the country that happen in the Midwest because they're just so profound. So you can see how tall they get. Wind shear turbulence, I think that's kind of a given here. You can see here another thing, and this is something that they talk about over here called squalls. Well, it's that sudden increase of that wind speed of at least 15 knots, and it's at least 20 knots of peak gusts, and they get a lot, those gusts become a lot stronger than that. Roll clouds that we talked about before when we looked at like the lee side of mountains with kind of mountain wave stuff, those can happen in like the frontal passage sections of a thunderstorm. They talk about the duration of these thunderstorms, 20 to 40 minutes, but you've got to kind of realize is that sometimes those storms, they can last longer, sometimes they're shorter. It just really varies. But again, you can count on some pretty severe localized weather for 30 minutes at least when those big storms move through. It really kind of depends. How fast are they moving? That's one of the things. If you have one of those big storms that just parks itself somewhere, then I mean you can have some severe weather for quite a long period of time. Localized flooding, severe lightning, and wind damage. So there's a lot of things that can happen with these thunderstorms. We're going to be getting and talking more and more about thunderstorms because as we go through weather, you're going to know that we start every class from now on with some type of a weather briefing that we do. But we're going to start to see, starting here next, well, actually probably more in March is really kind of where that we really start looking at this, at the conditions that are right to develop thunderstorms. So we're going to start watching those. But in these here, again, the illustration that you're going to see here now, this is kind of a picture of the thunderstorm. And I think you can see that these things are just pretty crazy. The big thing that we want to make sure that we do, that we avoid these thunderstorms by staying at least 20 nautical miles away from the plan view footprint of these clouds. When I talk about a plan view, that's from top to below. So if you were looking from the space station down at one of these thunderstorms, that's kind of the view I'm talking about. You want to stay a minimum of 20 nautical miles away from these things, if not more. We've been as close as 40 nautical miles away from storms, and it'll flat get your attention in a small airplane. So you kind of have to really give these things a wide berth. Now, the reason I say this is because as you look at this illustration, you can look here at kind of the width of the main body of this, in this case, one big cumulonimbus cloud. But remember that you've got this anvil cloud portion at the top of it. The anvil cloud will shape on the lee side of that thunderstorm. So you have your winds, your upper air winds pushing it this direction, so it's pushing it all this way. The reason that you want to stay 20 nautical miles away even from this leading shelf of this anvil cloud is because with these updrafts and downdrafts happening here, it is not uncommon to have hail, which is a pretty common formation inside these storms because this moisture gets pushed up and down and up and down. As it goes up, it freezes, it gets heavy, it starts to fall. A big updraft picks it up, pushes it back up again, collects more moisture, freezes again, gets bigger, starts to fall. Another updraft catches it, pushes it up again, collects more water, freezes, gets even bigger, and then at some point, just the weight of the hail itself, it cannot be contained inside this cloud, and it gets shot out. Well, sometimes it can get pushed down here underneath the cloud, but sometimes it can get shot up and pushed out over the front, this leading edge of this. I have seen a picture, and I've tried to find this, where you see this from the air. You see kind of this white, misty looking stuff getting pushed out of here across the front of this anvil cloud, and it just looked so peaceful. It looked so pretty, so serene. And then you ultimately find out that it was just like, you know, rocks getting shot out of the front end of this storm. And of course, you know, if you fly through that, well, you know, yeah. So you got to watch for that hail on those leading edges underneath the shelf of that anvil cloud. I'm not sure why this is moving so slowly. Now, the third stage. So remember, cumulus stage formation, mature stage, which is the big nasty right in the middle, the mature stage there. Then you have the dissipating stage. So remember, in the mature stage, you have updrafts and downdrafts. Now, as that storm kind of loses energy, cannot maintain itself much longer, then it just kind of gives that big, I'm out kind of a thing. When that happens, you have primarily downdrafts. So that air now is moving out of that cloud and then rushing down toward the ground. Again, you get some of that rain that comes along with it. You may get some of that hail that comes along with it, but you can also get a lot of wind. So remember, you have to kind of expect that as a pilot if you are landing somewhere around where a thunderstorm may have happened and now it's dissipating. You may have to kind of consider the ground effect of those winds as those things leave that storm. So you can read all about that there. Severe thunderstorms, as I said before, you can have storms that may just have one cell, is kind of like what we call like one big cloud. But then again, you can also have some of these huge, big single cell storms called a supercell, and those also can be bad. You also have this thing called squall lines, and we'll talk about that here in just a little bit. Embedded thunderstorms, these are of particular interest to pilots. So let's take a look here at figure 34.5. When you look at this, let's say that you're this airplane down below. Well, here you are below this layer of clouds. This is almost kind of this longitudinal stratus looking type of cloud layer that you might have here. And then down below it, you're below this deck. Now you see the water. You kind of know that you're going to get rocked around, and that's probably not the place you really want to be. Well, here you are. In IFR, you're in a cloud. It's in the warm summertime, and so you're not really concerned about icing because the temperatures are relatively warm, let's say, and I'm just, throwing this out. Now you're flying through this cloud deck. Well, if you're in here, you can't see with your eyes these big clouds. You can't see them. And so in this IMC level, God, I've just gone blank here for IMC. Instrument meteorologic conditions. God, finally kicked in. I just need more coffee. Excuse me. Pardon me. Hang on. Yeah, there it is. So when you're looking at those and you're in those clouds, you can't see them with your eyes. So you kind of have some weather information on your airplane, hopefully, that kind of shows you that you may be in areas where thunderstorms exist. Your pre-flight planning tells you that you may be flying through areas where thunderstorms may exist. But if you don't have onboard radar, you're not going to know necessarily what's out there. And so having those embedded thunderstorms is something that you're going to want to know. These reports, these are AirMets or SIGMETs, will talk about the likelihood of embedded thunderstorms. And that's just, again, that's a thunderstorm that is kind of in a layer of clouds that prevents pilots from actually seeing these thunderstorms. We look down here, icing. Yes, icing can be an issue. And again, we know that toward the tops of those clouds with the temperatures in the right conditions can lead to airframe icing. We also kind of look at that with the form of hail as well. And again, that heavy hail, it can absolutely destroy an airplane. You can Google pictures of airplanes that have been hit by hail, and it's really not pretty. Lightning. Is lightning a possibility? Well, hello. Yeah, it is. Can it hit your airplane? Yes, it can. And again, it's one of those reasons why we try to give these storms a wide berth. Sometimes a lightning strike can be, God, I don't want to call it a non-event, because anytime that lightning hits an airplane, you have the potential for catastrophic issues. There have been military reports of lightning hitting military aircraft that just completely knock out all the electronics and all the power to the airplane. And there's one kind of a famous story of one military pilot in some form of a fighter jet, and I don't recall the situations, where he actually had to punch out of his airplane in a thunderstorm. I know. And so the guy survived. It was it, but he was kind of messed up. He was hurt pretty bad. So that's just something that you kind of have to be aware of. Lightning strikes, again, we have the static wicks on the trailing edges of our wings, of our ailerons, etc. Those things called static wicks are designed, even when we're not flying through any kind of storm, weather, the friction of the aircraft getting shoved through that air mass creates that static electricity. We've all kind of walked around and shuffled our feet on the carpet and reached over and shocked Uncle Tom. Well, that's kind of, the thing that happens with aircraft. If there is something that touches it, then that spark can then get created. And if that happens in the wrong place, things could be bad. So we have those static wicks on the back of it to kind of gather that static electricity that forms as the aircraft goes through an air mass, to sort of dissipate that static electricity behind the aircraft. And that's what those are for. It's one of the things on our pre-flight that we always check to make sure that they're in place. We also kind of have to be careful because the attachment points are somewhat brittle. So you kind of have to be careful about how you handle them. If you touch them, you don't want to, pull around on them too hard at all. You just kind of want to make sure they're secure and move on. Make sure they're there and make sure that they're secure. So those are called static wicks. The turbulence, they talk about these in regard to types of turbulence, and it's a real subjective measure. I realize that it shows here kind of the definitions of these things. A slight erratic change in attitude or altitude. You may feel a little tug on your seatbelt as you get kind of bounced around in the cabin. But it's pretty subjective, because the first time that you feel a little turbulence, you may think that it's more in the moderate category. It's just like, oh my gosh, what is this? And then the more you fly, the more experience that you get, the more your opinion changes on what type of turbulence that it is. Because as you fly, especially flying around the mountains, you know that you're going to get kind of knocked around a little bit here. And when I say knocked around, I'm not suggesting that your head is going to be smacking off the canopy, because that again would be in that moderate to severe range there as well. And having had that happen, it'll when you regain your wits about you, you will realize that you can pull that seatbelt a lot tighter than you thought you could, especially with our seatbelts in our aircraft. Our aircraft are equipped with the AmSafe seatbelts, so they're airbags. And so sometimes you pull those things over and just the weight of the lap portion of this may feel kind of heavy. Well, you can cinch that bad boy up even just a little bit more to keep your head from getting whacked up into the top of the canopy. That's, not fun. So you have light turbulence, moderate turbulence, severe turbulence, then you have extreme turbulence. And remember what VA is, maneuvering speed. When you start getting kind of bounced around, remember that you've got to slow that airplane down to stay within VA. This is kind of where all of these things come into play. So you have kind of the effect of the turbulence, but then you also have the duration of them. Occasional, intermittent, continuous. So, and they divide those three up into thirds. How clever. So you have the occasional, intermittent, and continuous. So you've got 4 different types of turbulence, 3 different lengths of duration. You need to know those as well. Downbursts and microbursts. So do downdrafts or updrafts always have to happen in conjunction with a thunderstorm? So when you look at these, you can see that these downbursts or microbursts, and all part of these things that we sort of lump into the wind shear definition piece, is that these can happen in very small areas, and you can get big, strong downbursts, and I mean 2,000 to 3,000 feet a minute. It's pretty profound. I tell this story because in my instrument training, those many years ago, we were coming back from an instrument flight down in the southern part of New Mexico, and I'm in the hood, meaning that I have my view limitation device on. My instructor is sitting over here to the right. And the next thing I know, I feel something happen, and you kind of sense that air rushing here with the aircraft. We're in an updraft that's that's shoving our airplane up at about 2,800 feet a minute. And I'm trying to kind of lower the nose to try to keep altitude, but it became pretty apparent that I'm not going to fly out kind of from underneath this. I just had to fly through it. And so finally, after gaining about 5,000 feet of altitude in a real short period of time, we got out of it, only to fly into the downdraft of it. And so here again, your instinct as a pilot is to try to hold your altitude, and so you're pulling back, here until you realize, I'm not climbing out of this. And so you just kind of hold up your attitude, keep your wings level, and just pray that you get, fly through this microburst before you run out of altitude. And of course, we did, but it was just, the big thing that you can do is just try to keep your wings level. If you can find some kind of out, like lower terrain, that might be a consideration for you to kind of think, okay, if I need more altitude, I can find more of it over here, as long as you're not flying into some form of a box canyon or something like that. And otherwise, you just kind of make sure that you're in VA, make sure that you're holding your wings level. So, there you go. So, microbursts. You can look at the microbursts here. Some of these can come with precipitations. Some of them don't have to. Some of them can come right down here below clouds. And again, that's kind of why flying below a deck of cumulus clouds can also be pretty lumpy, because you get the updrafts and some microbursts that you have there. This kind of shows you here a typical life cycle of a microburst. And it shows here, basically a 10-minute kind of an event here. It can be shorter, it can be longer, but this is kind of the microburst. And you can see just how narrow this shaft of air moving here can be. They talk about these and exceeds 20 knots. Yeah, well, they can be a lot stronger than that as well. So, microbursts, know them. We look here again, and I'm not sure why this is happening here. What you're seeing here in this illustration that I'm showing you here right now, this is again, at the base of a big cumulonimbus cloud. If you guys Google Dallas, Texas, 1985, and L1011, this is almost exactly what happened to that aircraft that crashed in Dallas, Texas in the summer of 1985. And that accident was a landmark accident. Anytime you hear somebody talking about some form of a landmark accident, you can always think, well, something bad happened. And well, yeah, that's kind of true. With this, where that aircraft crashed, as it was shoved down to the earth here again, the crew got behind things. They were not expecting it. It was one of those things that even though you can kind of see it, it wasn't forecast. There was an aircraft that had gone through that exact same spot just a couple of minutes before that landed, but when he did land, he ran out of runway because of the tailwind that he landed with because of this event. But it was too late to get a message to the crew to get him out of that area. So now they have weather reporting stations on the fields of all aircraft as opposed to being off the field like they kind of used to do. And these are there to kind of detect this type of microbursts and wind shear activity here that surrounds some of these storms. So you can see here on this illustration kind of what happened, and it was really bad. I just remember it because I was there. The L-1011 hit the highway first. It killed several people on the highway before it smashed into a fuel tank on the field there at Dallas Love Field. The fuel tank, fortunately, did not erupt, and there were survivors of this, but there were not very many. So this is one of the reasons why textbooks now stress these types of things. And this is what you have to be aware of as a pilot, is to say, am I going to be here somewhere on my approach underneath the base of a big cumulus cloud? And this is kind of, what can happen. So you can read about this. You can see what this is about. What about on your takeoff? Can this also be an issue? And the answer is, of course, yes, it can. I can't cite an issue here where, a major tragedy that has occurred on takeoff on one of these things, but it stands to reason that the exact same thing could happen on takeoff here with this, where, regardless of the size of your airplane, you cannot apply enough power to outclimb that downdraft. And again, understanding which way the winds go as it gets closer to the ground on those downdrafts. So those are kind of a big thing. There is, when you look at the margins here, and these microbursts having been known to blow hundreds of trees down in a radial pattern and to blow trains off rails, there is, and I want to say it was in northern Colorado, it was somewhere near Steamboat Springs, and I want to say it was in the Zion Forest, the Zion Wilderness. You can Google this, and you can see that this happened. I remember this again because it's like I'm everywhere. That's just not true. But I actually was in Steamboat Springs that evening when there was a big storm that kind of came through, and then it was, I don't even know if it was the next day, but it was like maybe the day after that you started to see these pictures because someone flew over it. They had no idea that it happened in this section of wilderness, but you see this spiral, kind of a fan-looking area where these trees are just flattened in kind of this fan kind of a shape there. And that is what they attribute that, all of those trees getting mowed down was from a microburst. So let's think about this. If a microburst and one of these big downdrafts can destroy a forest, what chance do you have in a little airplane? Huh? Okay. Effects of a microburst on aircraft performance. Okay. So you understand you're going to have headwinds, you're going to have tailwinds, you're going to have things that attempt to push your airplane to the ground. You'll notice that we don't spend as much time about the updrafts, because normally in an updraft you're not going to hit anything real hard heading up. But heading down, we have this whole terra firma issue that we have with airplanes, not coming back to Earth the way that we had planned. And so this is it. you kind of hope that you can fly out of these things. But again, it's like sometimes you just kind of don't know. So that's what it is. Tornadoes, waterspouts. Remember a tornado? A tornado is that phenomenon, of it's like a model of like a super low pressure system where the air is turning anti-clockwise and going up. That's kind of it. Waterspouts, that's a tornado on the water. And again, they pull this air through here violently. They talk about it exceeding 150 knots. They are a great hazard and avoid them at all costs. See, it says that right there. Oh, look, thunderstorms are hazardous to aviation. Well, see, there we go. Again, good counsel. 20 nautical miles or more, yes, you want to stay out from underneath the footprint of a cloud. SIGMETs, these are significant meteorologic reports that go out. SIGMETs are for everyone. That includes the big boys. AirMets are the ones that are primarily out there for us little guys, that fly smaller airplanes. So note the bullet points here on the hazards to aircraft from thunderstorms. Note the bullet points. That will show up on a figure quiz near you. Now we talk about a squall line. I am going to try to find the picture that I have of this. I have it was on an old iPad, and I think it got transferred to the new one. I'm not sure, but I'm going to try to find it. Several years ago, there was a squall line. And what happened is that you have, you've seen the radar images of like this thunderstorm front that kind of moves, and in most cases it's sort of west to east or southwest to northeast or northwest to southeast, but it kind of moves in some form of an easterly direction. And when that happens, you kind of have a distinct front through there. Well, this thing can be 20 miles wide, it can be 100 miles wide, or it can be longer. I have a picture of a squall line, which is a line of thunderstorms, a line of continuous thunderstorms that began in Brownsville, Texas, which is kind of at the very south end of Texas, and went up to Chicago. It literally cut the nation in half. There was no east-west traffic and aircraft traffic that night. You couldn't get over these storms. The cloud tops were in excess of 50,000 feet, and you just weren't going east or west. And it literally bisected the nation. That's how big these things can be. So, guys, we just don't mess with these. That's the bottom line. Flying near an active thunderstorm. Surfing in a hurricane. So, this is, it's bad juju, and it's just something that you just don't want to do. You got to fly around these things, and you have to kind of think, how wide of a berth should I give these things? Well, if you can't get at least 20 nautical miles, and I'm going to suggest 30 nautical miles away from these storms, don't even mess with it. Sit it out. Sit down. Park. Have a cup of coffee. Read a book. Do something else. Because it's just not worth it. Wait till the storm passes. Then go. That's, kind of the thing. And I get it. People need to be places. Well, yeah, you do. You need to be places. You need to be around that table at Thanksgiving. You need to be there on birthdays. That's kind of what you need to do. You don't have to get somewhere in most cases. So you just wait it out. You can read about that, flying near there. Here are some, if you cannot avoid flying through or near a thunderstorm. Oh, God. All right. So take a look at these bullet points here. Again, VA is going to be the key. You got to get your pitot heat on, get your prop heat on, all of your anti-ice equipment if you have it anywhere nearby. Try to maintain your heading, try to keep your wings level, but don't try to make any big sudden movements with your aileron. Remember that at VA it allows you to make one full deflection of any one primary control surface. It does not mean that you can sit there and saw around on the rudders, because we know what happened in November of 2001 in New York. Try to avoid the turns giving you more G-loading there. That can also cause, you know, issues with your aircraft. Your airspeed is going to fluctuate. You just kind of have to keep it going. You got to watch the icing band of wherever you may be able to, you know, get into some ice. It's just so much better to be able to avoid these situations if you possibly can. This St. Elmo's fire, you know, it's one of these electrical discharge things that you see kind of with the result of a lot of static electricity in there. It's one of those things that it is, as the book suggests, it is spectacular. But you know what, just to go experience kind of that phenomena around your airplane flying through a thunderstorm is probably not the way to go. Just saying. All right, so there's thunderstorms. Okay. Now, some of these, hang on here, let me make sure I am doing this here. We looked at this. Am I going the right direction? I think so. Okay, those are just some additional illustrations there. So that takes care of chapter 34. Next, we're going to come back here with some high-level meteorology that we have, and we will do that on a next lesson. So guys, there you go, and we'll pick this up here next lesson. See ya. Oh, hang on, I got to turn this off. Yeah, this is kind of nutty. Do the lights work? Are the lights doing the thing? Do I look fabulous? Who knows? All right, there we go. Let's turn this off. Boy, this is kind of the awkward phase of these classes here is when I have to do this. Okay.